in the given question you will have to find out the second largest element. This is okay, second largest element. And if you are finding the second largest element, then how many comparisons you will require? So the normal method is what? n-1 comparisons to find out the largest element, and after that n-1 more, or maybe n-2, let's say, for second largest, right? But this particular approach is not the efficient approach. We will have to find an efficient approach. With that particular approach we can find out the second largest element within minimum number of comparisons. So we will use an algorithm that is our tournament algorithm to find out the minimum and the second minimum, or to find out the largest or second largest. So let's say I'm just taking few numbers, 8 numbers I am taking, okay, and these numbers are, let's say, 8, 4, 5, 6, 2, 9, 1 and 3. These numbers I have taken. Now what I will do is I will have to compare two numbers in the pair, and the largest number or larger number among those two numbers will go in the next step. Okay, it's like tournament. These two players are playing in the tournament, and the larger ranker player will go in the next step. So 8 will go from this pair, 6 will go from this pair, 9 will go from this pair, and 3 will go from this pair. Okay, again I'll do the same thing. That means 8 will go here and 9 will go here, and at the end among these two my 9 will win. Now we will count that how many comparisons we have done till now. One comparison here, number 2 here, 3, 4, 5, 6, 7. That means if we were having n numbers, then to find the minimum element we have taken n-1, not minimum, sorry, it's largest. So n-1 comparisons we have done to find the largest element. Now the actual algorithm to find out the second largest element starts now. That if we will think in that way, that my 9 is at the top, that means first ranker person is 9, that means I can understand that this particular 9 has won over all the numbers. So what I will do is I will prepare a list of those elements which has been compared to 9, just because my second largest element can win over all other numbers but not on 9. That means in all the comparisons, 7 comparisons I have done previously, among those 7 comparisons my 9 has been compared to my second largest number at some point. Maybe it is at this particular point, or maybe it is at that particular point, or maybe it is that particular point. So what I will do is, when I will start my all the comparisons, I will prepare the list of the numbers. Okay, so after first step I will have here the list of 8, list of 6, list of 9, list of 3. That means list of 8 will contain the number which 8 has with which 8 has compared, and the same the list of 6 will contain 5, list of 9 will contain 2, list of 3 will contain 1. In the next step I'll drop 2 lists and 2 numbers 6 and 3 I'll drop, and the list of those also I'll drop. So in the next step I'll have 8 and 9, 2 numbers and 2 lists. One list is of 8 and it will have 4 and 6, and another one is list of 9, and that particular list of 9 will have 2 and 3, and at the end we will have only one number and one list, and that particular list will be of 9, and in that particular list of 9 we will have only 3 numbers, 2, 3 and 8. What I will have to do now is I will have to find out the minimum, largest of these three numbers. Among these three numbers, the largest number is my second largest of all the numbers. So you can observe that if I am having total 8 numbers, then list of largest number will have total number is equal to log of n. You can easily observe log of 8 is equal to 3. So I'll have 3 members here. Okay, this particular thing should be the seal value of log of n if the n is not the power of 2. Okay, so if I want to find out the minimum of these three numbers 2, 3 and 8, I will require only 2 comparisons. Okay, so total comparisons now I will count is equal to n minus 1 for finding the largest plus log of n minus 1 to find out the second largest. So for the given question they have given n is equals to 64, so it should be 64 minus 1 plus log of 64 base 2 minus 1, so it should be 63 plus 64. Log of 64 is equal to 6 minus 1, that is 5. So for the question my answer will be 68. So 68 is the answer. 68 comparisons will be required to find out the second largest element among all n elements.